Hey guys, I recently came across OneUp Keyboard's Sweet 16 macro boards and decided to order 2 of those. These are completely programmable, they can trigger single keys, key combos, or even lines of text, and I've thought of multiple ways I could use them. I could see myself using one at work to set breakpoints in my code, compile, or other debugging shortcuts. Although most of these are already available through function keys, it would be nice to have dedicated buttons for that. It could also be useful for video editing or launching some of your favorite apps. I could also see these boards used for gaming on the go, with games that don't require a lot of keys. Let's say you have a gaming laptop and want to have a mechanical feel without having to carry a whole keyboard. So I built these, and I also made wooden cases for them, and we'll go through all those steps in the following. So these are all the items you will need for the soldering steps. All of these can be purchased from OneUp Keyboard's website, so you'll need 16 diodes and a Pro Micro board, rails for the Pro Micro and a reset button, 16 PCB mount cherry style switches, I went with Gateron Browns, a Sweet 16 PCB, a pair of flush cutters, and a soldering iron. You will also need a fan to make sure you're not exposed to the fumes, and I got this one from Arctic that was recently sent to me. It has variable speed control and it's powered via USB, so it can be paired with a power bank, making it wireless. I wouldn't need something like that normally, but it's been quite useful for the few soldering projects I've made recently. Now here's a closer look at the PCB. It's bare bones, so we've got a lot to do. OneUp Keyboards made a detailed tutorial on how to solder that thing and flash it, so I would encourage you to check their video if you want to make sure you're doing everything right. Their video is like 25 minutes long and more detailed as well. So I started by soldering the rails on the PCB. These will be used to install the Pro Micro board. The soldering rings are really small and my soldering iron is not that great, so mixed with my below average soldering skills, it didn't end up as great as it could have been. It was hard for me to touch the ring with my iron, so it wouldn't melt the solder. Still, it's not too bad when you look at it. Next step was to bend the diodes. I bent both pins to a 90-degree angle and all 16 of them. Here's an example. The only thing is you have to make sure that you don't break them as you don't get spares. I inserted all of them in the PCB following the mounting direction that's printed on the board. The diagram shows you where the darker line should be. I also folded them down so that the PCB could lay flat. I soldered all of them from the front and it was easier this time as the ring was larger. You can also solder them from the back, but it seemed easier that way. I then cut all the excess using my flush cutters. I made sure to hold the pins while I was cutting them so that they don't hit something by mistake, like my eyes. And here's a look at the front where the cuts were made, and a look at the back where the solder points and the diodes are visible. Then I installed stand-up screws. They're not the ones that OneUp Keyboards sell, but I would recommend you get these as they look much better. I only ordered one set of legs, but should have ordered 2 as I had to DIY the other pair. I soldered the reset switch simply by heating up the legs and then melting solder over them until some also got under the leg. Then I was ready to install the switches. Since these are PCB mounted, I simply needed to apply pressure and they were in place. Here's what the underside looked after that step. And here's how the switches look like when installed. So I went ahead and soldered them down. For every switch, I soldered the 2 pins that create the electric contact when actuated. It's not super hard, but it takes a bit of time. Again, make sure your switches are fully inserted in the PCB as you could solder them at an angle. I also needed to press down the switches most of the time to make sure I was working on a stable surface. And here's how it looked after that step. The last soldering step was for the Pro Micro. After inserting it in the rails, I soldered every contact point. Again, the soldering rings were small, so I had to be precise with my iron. And here you can take a look at my soldering job. I finally cut the pin excess using my flush cutters. It looked much better that way and prevented potential scratches on my desk. I then used a magnetic adapter with that board and I connected it to my PC to see if everything was working. I won't explain how to flash it with your own layout as OneUp Keyboards explain it well, but I was able to reprogram it so that it matches the keys around the WASD area of a regular keyboard. Now that's all great, but I wanted it to look better, so I made a custom case. For that, I asked my dad to help me a bit. He also had multiple tools that I didn't have on hand and knew that we would need. Again, we didn't use the best tools for the job, but the result isn't bad, so I'm still happy with what we did. But if you're a woodworker, you might disapprove some of the following steps. So we used wood leftovers from one of my dad's projects. That's African walnut and it looks awesome. We started by cutting it to the initial dimensions we wanted for the case, then we drilled the holes in it to use a jigsaw afterward. It's not the best tool for the job as it's hard to make perfect straight lines with it, but that's what we had on hand and the blade we used weren't great as they chipped the wood a bit. We also drilled holes for the board standoffs using a drill press. Again, the drill bits we used weren't sharp enough so they kind of burned the wood more than anything. As you can see, there was a bit of smoke. Then we tried to see if there was a fit and it didn't exactly, so we had to rework some of the holes. After a few trials and errors, we were pretty close. A lot of rework was involved, it took us over an hour for the two cases, and we worked on the dimensions and holes more than once. So this is the unfinished result. It will require a lot of sanding as it's uneven and a bit rough, so we'll get to that right now. So I used various sanding techniques, starting with a sanding plate that helped to get straight edges that were messed up by the saw. It was still a manual process and wasn't perfect, but after a bit of work, the edges looked much better. Then I used 60 grit sandpaper and sanded off the rougher parts. That was a long process as we had chipped the wood at some places and the inner edges weren't straight either. I tried sanding alongside the grain of the wood first, but I gave up after some time as I had a lot of work to do. After that, I used 220 grit sandpaper to finish the surface. The 60 grit sandpaper would kind of eat the wood and scratch it, but I used this one to round the edges and leave a smoother surface. And after I was done with both wood pieces, I was ready to apply the polyurethane. I used a small 3/4 inch brush for this step, and I used Minwax fast drying polyurethane. I had some left from my desk project that I did a while ago, and I will have a card on screen somewhere if you want to check that out. So I started with a coat under the wood pieces. I will only apply one coat there as we won't see it when in use. I've done that to get the same color everywhere. I also did the sides at the same time, and then I let it dry. Here's how it looked when it was dry. I flipped them over and applied a coat on top and on the sides again as well. Some of the poly reached the top, but I will sand in between each layer so it shouldn't be a problem in the end. So I finished both pieces and let them dry overnight. Then it was time to sand them. I think I used 320 grit sandpaper to do so. The goal was to remove bumps and imperfections caused by the brush, so I was delicate to make sure I didn't scrape off the coating. I then removed the sanding dust using a damp cloth, and I was ready to apply a new poly coat. So I did exactly the same thing I did with the first layer. You can see that it's getting glossier the more coats we had. Again, I made sure to remove most of the drops that had formed and let it dry overnight. So I did the sanding, damp cloth, and polycoat steps once more. That was the last coat and would result in 3 coats on top and 1 on the bottom. This time I wouldn't sand another time, leaving the finish as it is after the drying step. And here's the final result. It's nowhere near perfect, the sides aren't perfectly straight, the coating isn't flawless either, and I couldn't get rid of all the wood chips, but I honestly think it doesn't look bad. Although it's not the same wood than my poker's custom case, I think this one uses yellow rosewood while we used African walnut. It's still not that far off in terms of color. I'm really happy with the result and I can't wait to see how I will use it in real life scenarios. For a first time, I think this project looks awesome and I'm happy that it works. One of my Sweet 16 boards had some switches that wouldn't register, so I had to bridge them using an external wire. That's a bit like hand-wired keyboards work, and it was cool to learn how to fix a burned PCB. I probably left my iron on the board for too long. The only downside of that case is that it's held down using gravity, so it wouldn't be great as a traveling keyboard. I would personally choose to leave it in place. But other than that, it's pretty cool. In the future project, I will definitely consider this aspect and try to make a better case out of those learnings. Again, using a magnetic micro USB cable with this is great, as I can easily toss the macro board aside and use the cable to charge my phone or mouse, which also have the magnetic adapter in when I don't use the macro board. This results in less cables on my desk, which is always a good thing if you want a clean looking workspace. I will have links down below in the description if you want to check out all the items I used in today's video, if you wanted to make a similar project. And if you make one of those macro board and make a custom case too, feel free to send me a link to it. I will gladly take a look at it and get inspired for my next project. On my boards I use DSA keycaps, but you can really use any keycaps you have laying around. As an example, here's another variation I did using OEM keycaps. I think it looks really nice too. So hope you guys enjoyed. Make sure you liked the video if you did, and if you didn't, just let me know what I should change down in the comments below. Otherwise, don't forget to subscribe if you still haven't already, and I'll see you in the next video.